Thank you, Maureen. As a kickoff, I'll tell you about my role at the company, and then I'll let each person tell you about themselves. First of all, today we have myself. I'm a principal consultant at Cambridge Semantics, and we have Ian Bone. He's the industrial engineering manager at Broadcom Limited. We have Hicham Wazni. He is the Director of Manufacturing Intelligence and Smart Manufacturing at Helmet Aerospace. And finally, we have Trevor White. He is the Group Manager for Manufacturing Engineering Systems at Toyota Motor Corporation. By way of kickoff, like I said, I'm a principal consultant with Cambridge Semantics, which is based in Boston, Massachusetts. My role there is to provide data management technology and architecture solutions. Since we are a software company, much of our work revolves around using our platform to support data management and analytics requirements. However, due to my background as an enterprise architect and systems engineer for U.S. Department of Defense programs, I do a lot of writing and presentations for DoD audiences on topics related to data interoperability, digital transformation, and related areas. I've worked in systems engineering and lifecycle support for about 35 years. And with that, I'll send it over to Ian.
Hi, my name is Ian Bone. I'm the industrial engineering manager for Broadcom, the wireless semiconductor division. Our factory makes radio frequency filters for high-end smartphones. My team and I are responsible for the long-term planning of the factory, as well as the execution of various continuous improvement projects. Over the past 4 years, our focus has been on implementing Industry 4.0 projects to automate our previously fully manual environment. We have a 200 millimeter semiconductor factory. So for those of you that are familiar with the semiconductor industry, 200 millimeter is typically older equipment. Myself and other members of my team come from 300 millimeter fully automated factories. So we've been taking what we learned in those state-of-the-art environments and applying them to more legacy manufacturing.
My name is Hicham Wazni. As the Director of Manufacturing Intelligence and Smart Manufacturing, my role is to lead us through the digital transformation and specifically to initiate smart manufacturing in the plants that have not yet started the journey, accelerate it in the plants that already have started it, and support the plants advance in the machine learning phase, in the plants that are data rich. And last but not least, make it part of our operational and leadership culture.
Hello, everyone. My name is Trevor White. I am the group manager responsible for IT in the manufacturing and engineering area within Toyota. My group has responsibility for all the applications supporting our North America manufacturing plants. This includes productivity, production instruction, plant maintenance, logistics, quality, and our digital engineering area. I also have responsibility for our Industry 4.0, our manufacturing IIoT program, where we've established a big data platform and analytics strategy supporting manufacturing. We're different levels of maturity from a data analytics perspective, depending on the functional area, with predictive maintenance really being the lead with over 6,000 rank A heat and vibration sensors. So I'll talk a little bit more about that a little bit later. Thanks.
Thank you, gentlemen. I'll start with a opening statement and then let each of you comment to that, and then we'll jump into some specific questions that we've developed ahead of time. Okay, so this session is about developing an advanced analytic strategy that optimizes factory processes and productivity. However, it's easy to see how this idea applies across other domains and other areas. In fact, deriving insights and new information to support improved decision-making is arguably the core goal analysis and is broadly applicable. If you consider a cycle or a process for insight creation, it can be divided into 4 stages: collect data, process data, analyze data, and then act on the findings. We observe that data is typically not the challenge, at least not in the macro. Many, if not most enterprises experience an analysis bottleneck. In other words, a disproportionate part of the insight cycle, if you will, is spent in the data processing stage. For example, the International Data Corporation, or IDC, a market intelligence company, states that 73% of the overall cycle is spent on data searching and preparation. In other words, data processing. Therefore, a critical enabler to a successful analytics strategy is effective and efficient data processing prior to analysis. In fact, one of the byproducts of data collection, which again is arguably not the biggest problem area or challenge in the macro, is known as the data lake. Essentially, it created a large repository of unprocessed data. I think the advent of data lakes was a tacit acknowledgement of the unmet need for improving the process stage. New architectural constructs like the data fabric apply technologies and methodologies to harmonize and provide frictionless access to integrated data. In other words, data fabrics seek to overcome the limitations of simply co-locating data in data lakes. The idea is to create an interconnected information layer for more seamless and on-demand access for the analytics. Another dynamic contributing to the need for seamless access to information is uncertainty. Organizations must assume and even embrace the unexpected. Therefore, data models and practices that assume change are more responsive and adaptable to the unforeseen. Additionally, to move into areas like predictive and prescriptive analytics, the enterprise must, quote, know what it knows as a prerequisite to advanced analytics. In other words, the enterprise should establish an understanding of the data that it already uses and then figure out how to, quote, de-bottleneck the data process stage. This is where modern architectures such as the data fabric apply. Gentlemen, would you like to provide your thoughts or maybe respond to what I just said? We'll go in turn. We'll start with Ian.
Sam, I think you touched on many of the key points as far as what the steps are that an organization must take to implement some of these strategies. First off, you need to decide what your initial end goal is and correctly scope the project. And then you need to perform an assessment of all your existing data systems to determine what you're missing. And then really figure out how to bring that data into your system efficiently so that you can use it and make a decision based off of it. In our case, we were running our factory completely off of manual instructions printed out on paper physical run sheets. And we had no location tracking for our material in the factory. So we had all of this human glue that was holding our factory together, which created a lot of inefficiencies. So we resolved this by bringing our run sheets on the system, implementing RFID tracking, and that really gave us the missing pieces to tie everything together and do exactly what you're talking about.
Very well, very good. Hicham?
Yeah, I mean, those are good points. And, predictive and machine learning phases are more mature stages in the digital journey. There's a lot that can be done in the early stages, well before you hire data scientists, to clean and do magic with your data. I mean, for instance, once once you have your MES on board and you have, added all the sensors on your machines, you would want to add thresholds and alerts to the systems to monitor the asset condition so that you can measure the asset performance well before the asset starts to drift. For example, if you have a machine with bearings, you would add sensors to measure bearing temperature, bearing vibration, set the alerts level so that alerts can be sent to your maintenance technicians, to your engineers, so they can react early. And so this will trigger the maintenance, personnel to look at the equipment during breaks or during planned maintenance instead of letting that, let's say, that bearing run to failure. So these are early wins in the digital journey, again, well before you are very data rich and before you hire, data scientists. And definitely, adding those sensors onto existing machines will evolve based on the needs of the organization, and making sure that the digital culture has evolved enough to accept predictive and machine learning stages is an important milestone in the journey.
Agreed. Trevor?
Yeah, it's a great topic, and one we've really focused on from a manufacturing perspective. We found the biggest benefit coming from, as I mentioned earlier, kind of our predictive maintenance area. We run a Maximo, but we partnered with a small company called KCF, and we've got 6,000 sensors out there on our rank A equipment for monitoring heat and vibration, and having that ability to link that into Maximo to create those predictive type of analysis to understand when a piece of equipment is starting to fail and taking action on it has significantly reduced downtime. We've seen a huge amount of reduced downtime and improved operational availability from that activity. The culture at our plants are starting to change, where they're starting to really use that data to truly drive real-time decision making and making changes. So, this predictive maintenance, if you haven't picked a good use case, it's probably one of the best ones, that and energy to start out with, to start down your journey. So it's been really good for us.
Very good. I know that, especially as the senior decision makers, they want to get into predictive and prescriptive analytics. And I think a common theme among the panelists is kind of this idea of walk before you run. So when I say know what you know as a prerequisite, we could also describe that as descriptive analytics. So going back to, I think it was Ian's point about understanding what is the end goal and then identifying gaps, specifically information or data gaps. This whole idea of inventorying and understanding what you know before you get into the more advanced analytics is a perhaps not exciting but essential activity for long-term success. If an enterprise doesn't do this, then surely they're going to make erroneous decisions based on partial information, and we're going to elaborate on that in a little bit. So moving on to another topic, what role, and this goes out to everyone, what role does an advanced analytics strategy play in improving factory processes, uptime, and productivity? And can you give us some examples? I'll start out with a few comments, and then we'll go in turn and let each person provide their input and perhaps response to my comments. I would argue that a successful strategy, going back to what we just said, provides complete and precise information from which analytics will derive new information and insights. In defense communities, there's a concept called the decision cycle. The idea is to get through that decision cycle faster than your opponents. That is to say, faster than your competition. However, if the demand for actionable information is so great and the underlying analytic apparatus is not efficient or it has gaps, then analysts will necessarily offer what amounts to conjecture to decision makers. We can call this a dangerous shortcut because it bypasses proper analytics and it becomes a vicious cycle and leads to undesired outcomes. So to avoid the dangerous shortcut and provide the best analytic outcomes, data must flow to and through the analysis stage with minimum friction and maximum context. Context implies a complete and accurate understanding of your domain of interest. For example, in a manufacturing setting, if the analytic is unaware of all the factors influencing a given machine in an assembly line, it may not make the best predictions for maintenance. Artificial intelligence is another popular trend, and the same data dynamic applies. In other words, without effective information architecture, enterprises will struggle to operationalize AI initiatives at any meaningful scale and effectiveness. With that, Ian, would you like to talk about that?
Sure. So in our case, implementing an advanced analytics strategy and factory automation strategy has been a way for us to uncover and resolve lots of our hidden factory inefficiencies. So in all factories, especially older factories, there's lots of human glue between shifts and operations to keep things running efficiently. From one day to the next, each operator performs a task differently. And this operator is only able to process so much information effectively. And often it's only information that's in front of them on a screen or physically in front of them on the floor. So all of these factors contribute to the variation in your factory, which negatively impacts your production. So by bringing all of these factors online and into your production systems, you can create these automated and optimized decision-making logic to drastically improve your efficiency. So in our case, by bringing everything online and automating these decisions, we've been able to see a greater than 10% improvement in our factory idle time. So this was achieved by making these better, more informed, real-time decisions, and then depending on the operators on the floor to effectively execute those decisions as smoothly as possible. And because this data is now real-time, we're able to constantly adjust those decisions based on the demands of production and the changes real-time on the floor, which you could have never done before under that manual operator decision-making environment.
Very good. Hicham?
Yes, I mean, I'll add by emphasizing that advanced analytics is a critical step in improving output, equipment uptime, and what have you. I'll share a shop floor examples that I was involved in, and I'm going to call it the spray optimization process. When forging product, typically you have a die set where you are forging the metal within that die. And you spray the internal components of the die, with a lubrication so that your metal can flow properly so that you can forge your product. So traditionally we had, operators with knobs kind of, moving the settings, looking at the spray pattern and trying to determine what good looks like from a distance, especially in a dark environment. And it was not always successful. Too little lubrication prevents the metal from flowing properly and you have problems in terms of quality. Too much lubrication can also lead to void and cracks within the metal. And it's just costly to lube too much. So by adding smart sensors and measuring the spray pattern, the amount, the pressure, the speed, the viscosity of the lube, we were able to gather enough data and then create a machine learning based algorithm which optimizes and provides the best lubrication and lubrication pattern within the dyes. And what that does is it eliminates the subjectivity in the process. It cuts on scrap and quality issue, and it enabled us to increase output. And again, this is one of many examples in terms of where advanced analytics enabled us to bear fruits in our smart journey.
Great example. Trevor?
Yeah, thanks, Sam. Appreciate it. Yeah, all great examples, and I could go through one by one at all the use cases, but I'll talk a little bit more at the macro level. When we established our big data platform, we call it Toyota Big Data Platform with our analytics team. We've got a COE that is focused, Center of Excellence that's focused on analytics. And while those are huge accomplishments, I'll just say, for this audience, you have to make sure that your culture, changes, right? You need to make sure you drive towards that data-driven decision-making first, especially in manufacturing. We had it ingrained in our DNA, Toyota DNA, that what problem solving is, but a lot of that was manual. So we've really had a big shift to utilizing automated data from the single source of the truth, and we're educating our manufacturing members on how to develop dashboards in Power BI, for example. But this was key. This was key to shifting the culture and shifting the way that people use the data, and on the factory floor especially. So we've made really good progress over the last couple of years. It's really proven out here lately with the whole COVID activity around visualizing how many team members are impacted and where it came from, and contact tracing and number of people out on quarantine. Having that data real time so that you can make decisions around, am I going to have enough people to run the assembly shop, or am I going to have enough people to run the plastic, paint shop? So those are other just more recent examples of how having that advanced analytic strategy is so important. But like I said, you have to really focus on changing the culture of how you drive from a data-driven perspective. But it's definitely helped us, especially recently. But it has to be top down. You have to have an executive sponsor that's really driving the cultural change. The other key factor for us is making sure that you determine what are your metrics, what are you trying to measure, and use that to drive your data and what's collected and how it's visualized from a KPI perspective. Those are some of the key points for us.
I think that is great. I especially like the point about the culture, the idea of accepting data-driven recommendations is challenged, I would argue, in part by the fact of data gaps. For example, if you have an analytic output that leads to the selection of a certain course of action, and it is later determined to be flawed, if you do root cause analysis and go all the way back, you will inevitably find that you had data missing. That missing data led to, for example, an erroneous conclusion, which leads to criticism, and that leads to kind of a stiff arm from the culture. They don't want to accept it because they know intuitively that something's wrong. So I would argue that it goes back to this idea of knowing what you know, and then developing those advanced analytics to make sure that you closed all of the data gaps, if you will, before you apply the analytic. And then, Trevor, you also mentioned across the shop floor. So that leads to who should be involved in the analytic strategy. In other words, what department and functional roles should be included in the process. And I would argue for a holistic approach. For example, consider an aircraft jet engine refurbishment plant. It is not sufficient to digitize only the plant equipment. The effective strategy has to include and integrate things like heating, ventilation, air conditioning, cyber, physical security, personnel systems, etc. Everything that has a role in this overall organization. From an organizational perspective, I think it's important to include roles or people or resources contributing to the overall strategy. In other words, each person brings capabilities, limitations, and contributing influences, and they should be modeled as part of the overall operation. Ian, Hicham, would you guys like to add to that?
Sure. I mean, the manufacturing process really encompasses many functions, and the digital journey needs to encompass those same functions. For instance, IT implements the MES system, maintenance installed sensors and wirings and what have you. Engineers program the PLC, the MES alerts and the thresholds. Employees react to alerts to improve the process. Data scientists clean the data and develop optimization algorithm and move us into the advanced analytics stage. HR sets up the right hiring strategy and organizational capability. And of course, leadership enables us, right? They enable all of those resources, enforce accountability, and enable employee engagement systems. So it takes all to have a smart manufacturing culture, and therefore it takes all to have an effective data and advanced analytics strategy. Ian, your thoughts?
I agree. I think Trevor hit the nail on the head as far as changing the culture of a manufacturing environment. You can kick off these projects, and if at the start you don't clearly identify all of the stakeholders and involve them in the process and get them to understand the full impact and the scale of how this is going to affect them and hear their voices and make them part of the process. When it comes to implementing the project, you're going to have a lot of challenges because you're going to kind of be throwing something on them that they may not be bought into yet. So having that top-down approach is extremely helpful for any of these, and doing that stakeholder management work up front will really help make your project successful and cut down some of the challenges on the back end of your project.
Well said. Okay, now we're going to move into lessons learned, and this question is kind of targeting Trevor and Ian, but we have plenty of time, so Hicham, if you want to weigh in, have at it. But it says, what are some of the biggest lessons learned in your advanced analytics strategy from the shop floor all the way up to the leadership of the company? As a data guy who works in a number of different domains, I've always found that from a technical point of view, I would argue the biggest factor is adaptability. We always go into a plan with certain assumptions and certain desired outcomes or answers, but as soon as it actually starts or somewhere during it, the plan changes or things just didn't go the way you expected. And technologies that plan or expect change are the ones that are going to be more capable of adapting with the operations tempo. You can't just say, I want a flexible technology. as a decision maker, it's important that you go into understanding what does it mean to be adaptable. And a place to start, in my view, is the study of complex adaptive systems. And the idea is that relationships emerge out of need, and sometimes your competitors are become your teammates, and sometimes requirements today are totally forgotten about tomorrow, and certainly new requirements emerge. So I think as a senior decision maker, it's important to intentionally and explicitly seek out and adopt adaptable technologies. Ian, Trevor, would you guys like to comment on your lessons learned?
Yeah, sure. I'll kind of start out and then turn over to Ian here. Thanks, Sam. So a couple of things that we've learned through our program. Number one, make sure you pick a really good strategic partner. As you can imagine, a company the size of Toyota in North America, we've got a lot of people on the plant floor that we have to touch and train and understand the requirements. So having a good strategic partner, not just to build the technology and the platform, but also to help you work with the different business groups to understand where your biggest opportunities are. I think having that platform integrator is very, very important. So definitely pick your strategic partner carefully. We went through a pretty elaborate process to establish ours, and it's definitely paying off. Number two, probably, make sure you have a really, really strong business leader for the program. Typically it's really somebody in the C-suite, executive sponsor. I'm on the IT side, so just make sure that you're also partnering with the engineering side, right? The engineering and IT really has to be lockstep on your program, and you have to really be almost an integrated team to be successful from what we've seen. Maybe the third one is a little different off the wall, but for us, having a very well orchestrated marketing and education and communication plan, I think, we subscribe to the build it and they will come initially, and they didn't come. So we really had to kind of go back and do a fairly heavy marketing effort to explain, the platform and the analytics and what we had done and what the benefits of it is, and really pick a couple of good use cases and showcase those and what the benefit is to really, educate, all of the different engineering and business groups or manufacturing groups as well. So I think marketing and education is also a really good one. Make sure you train your team. I'm a member of the MESA organization, which is a really good education method. Gartner, is another good one. Send our members to IoT conferences like this, right, and help them learn. But they really have to understand the technology and understand, where the opportunity is. Those are some of the big ones. The only other thing I would say from a platform perspective is be ready to integrate to vendor clouds via data forking. So we ended up, partnering with, like I mentioned earlier, companies like KCF, where we have to fork the data over into our big data platform. So make sure that you're ready for that. So those are just kind of some of the key lessons learned around, resources that are necessary to be successful.
Thank you, Trevor.
Trevor, it sounds like even though you make cars and I make computer chips, we're doing exactly the same thing, have exactly the same challenges. One thing that I'd echo is no matter how intuitive you may think this new production system is, you always have to put in the necessary training to ensure a smooth implementation. Early on in our process, we skimped on that because we thought, this is as easy as it gets. All you do is follow this list on a computer screen. That's all the operator needs to do. But really, everyone needs to understand everything behind what's going on behind the system. Your system could be revolutionary, but if you don't effectively show people how to use it, it's going to fail. And all levels of the company need to understand what it's doing, from the shop floor to the leadership, so that they can understand how it impacts the business. and so that you can really adjust everyone's expectations for what's going on the factory floor.
Thank you, Ian. Hicham, did you want to add to that?
Yes, I mean, yeah, certainly. I mean, Trevor, Ian touched on just about everything. There's one point I can add. If you look at our organization, we're comprised of business units, and a business unit is a group of plants geographically, located around the world that tend to make the same product or similar for a certain part of the airplane. So it's important that the business unit declares standardization, meaning the same platform. All the plants in that business unit need to implement the same MES so that you have a uniform journey among all the plants. You don't want each plant choosing whatever platform they want. Otherwise, it's going to be very, very difficult to advance. So by having a standard MES platform that all the plants in that BU can implement, you can develop a center of excellence that can support the plant in their journey, support them with their use cases. It's going to be a lot easier for the data scientists to mine the gold, right? Mine the data, if you will, if there is some standardization in that platform. And again, that is declared upfront early in the journey, and making sure that the plants adhere to it is an important part of that journey.
Thank you. Thank you, Hicham. So for the audience and the panelists, we have one more question, and then the last part will be to provide any parting tips to the audience. This last question is, how do you ensure you have the right talent and the right resources in place when the time comes? For example, data scientists to interpret the data and the analytic outputs. And also, what are your thoughts on full-time versus outsourcing? And I'll give some comments initially and then turn it over to Hicham and Trevor, and then of course Ian, if you want to weigh in as well. I would say that if the strategy is holistic, and a couple of things we heard from the panelists were things like integrated, across the board, training, those kinds of things. So it kind of harkens back to the holistic approach. And if you do this from a technical and people and design point of view, the argument is that the focus, the relative focus of all of the resources involved in analysis will shift more toward analysis and response and less on manually intensive and error-prone, what we call transactional workflows, meaning, for example, a data scientist converting a file from one format to the other, bogged down in these low-level details, and allow the system, the technology to do that, and allow the users to focus on the actual higher order cognitive tasks. And I would argue that I'm not sure. I think the best analysts are the ones who understand the domain better than anyone. And personnel who have more to lose are the most likely to succeed. So I'm not sure how you outsource conscientiousness, right? Ownership. I think that the technical solution should abstract the implementation details and allow analysts to focus on higher order cognitive tasks or activities. With that said, Hicham, I'll turn it over to you.
Yes, Sam, thanks for your comments. And I really like this question because I believe that smart manufacturing is about people as much as it is about technology. Because technology is already here. You have vendors knocking on your doors wanting to sell you, just about anything that you want. But people are the needed ingredients that make this digital culture, successful. And talent can be brought in either early on if you have, a lot of resources, or you bring your talent by phases. I mean, early, in the early phase, you're putting your MES, you're going to focus on bringing your automation engineers, your automation technician to implement the MES and support it. Then you're going to focus on your supervision and your shop floor leadership to train, develop, and instill that culture, that digital culture in them. And then as you have collected data, then in that later phase, you're going to bring your data scientist. So you also have the option to outsource data science. There's a lot of companies that do it for you and do it successfully. You also have the option to start with an outsourced data science strategy, prove use cases, generate some value through those use cases, and then earn the right to hire your own data science team, who then can carry the torch and, of course, democratize the the entire process and continue to generate value.
Thank you, Hicham. Trevor?
Yeah, so in Toyota, in our area, we use our data scientists. They're in IT, but we do have a role that we call citizen data scientist, and it's really a role in the business side, where they're performing, the data scientist role, but are on the business side and know the business process in and out, right? So we also have a cross-functional role, including a platform lead. We're following Scrum and Agile, but our full-time team members are really performing that product owner role. We have contract resources I mentioned earlier with the strategic partnership that are performing the more of the development and or Scrum Master roles within the Agile organization. But definitely where we see the greatest benefit from analytics, especially in the manufacturing area, is where we have those citizen data scientists or a leader in the business that's driving, through using that data to transform their business process, and they're learning how to use that. But that's what we found that is providing the greatest benefit right now in terms of making sure that you have that citizen data scientist or that strong leader in the business side. Those roles are critically important to being successful.
Thank you, Trevor. I'm going to go ahead, because of time constraints, I'm going to go ahead and shift us to the last part, which is basically what parting tips would you offer the audience? I'm just going to close real quick with some comments and let each one of you say something as well. I was going to say very early in my Navy career, I attended a micro miniature electronic soldering course. And the biggest lesson that I learned out of that, and I think it applies here, is that the instructor said that basically 90% of the effective soldering process was preparation. The actual act of soldering was a small portion. So similarly, I think that the best strategies place the premium on the prerequisite activities related to data architecture. It's the universal garbage in, garbage out principle. It's just not that exciting, but it's so important. And if an organization doesn't focus on the effective preparation of data from an architecture perspective, they're going to perpetuate this manually intensive and error-prone data stitching activity that not only results in partial answers, but it also keeps valuable brain power focused on low-level tasks. As for the analytics themselves, I would say treat them like services from an architecture point of view, so that the concepts and practices of service-oriented architecture will prove to be a useful ally. For example, develop an analytics taxonomy, rationalize analytics with business objectives, make sure modularity and reuse are part of the non-functional requirements. So in a very real sense, the practices and methodologies of service-oriented architecture will overlay nicely with the actual management of the physical analytics themselves. And if you rationalize each analytic, then you have a business case for it, and you're not just idly allowing people to develop capabilities that may or may not be applicable to the business. And with that, I'll turn it over to Ian.
My parting tip, from my exposure to other companies and factories through various types of benchmarking, what I've seen is that organizations can be a little overwhelmed at the start, and they have trouble selecting the right project to start with. The first project doesn't need to be automating your entire factory. That's impossible. That's crazy. But there is a portion of your factory that you can improve, identify it, think about what you need in order to improve that in terms of data and bringing that onto the system. It doesn't even need to be something that costs a lot of money. Some companies are paralyzed by not having the budget to do certain things. These things don't need to be expensive. And what little money you will spend on it, chances are you're going to have a significant ROI in order to justify that. You just need to think hard about what it is you're doing, what you're targeting, what are your KPIs, who does it affect, and really having the right people in place to make these projects happen.
If I can add, I mean, my parting tip, lesson learned, is really starting small and scaling up. You know, and I'll quote Jack Welch, who said, "When the rate of change on the outside exceeds the rate of change on the inside, you know the end is near." Well, you know your competitors are on this smart bandwagon. So as an organization, if you already have not started, it is imperative that you start for the survival of the organization. The benefits are tremendous, and you know, partnering with the right supplier is important. Preparing your employees for this journey is important, and the hiring, the organizational capabilities, all these are critical elements. But again, it starts by starting small and scaling up, you know, from there.
Yeah, thanks. This is Trevor. So for my parting tip for everybody, I mentioned it a couple of times, but I'll just reiterate, you know, develop a cross-functional organization and a strategy with business, engineering, and IT. That's number one, definitely recommendation. Have a strong executive top-down sponsorship within the program. Make sure you work to educate and change the culture to a data-driven decision-making. And then maybe the most important, just start small, have a couple of high-value use cases that show big benefit, like maintenance and energy, and that's proven to be a good recipe for us. So that's it for me.
Gentlemen, thank you so much for your time and your expertise and your thoughts. I think this about wraps it up. I think we could all agree that we'd recommend starting holistically, start small, and scale fast. And with that, I'll conclude this session, and thank you so much again.
Thank you.
Thank you.
Thank you.